Hello my dear students, this is Akash HD. Welcome to the AHD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions based upon the horizontal projectile motion and some basic concepts also we will cover. Okay, so let's start the video. First question is here, very interesting question. A bomb is dropped by fighter plane flying horizontally to an observer sitting in the plane. The trajectory of the bomb is a which one? And here you can see some options are available like a hyperbola, parabola, straight line, is it? So let's see how the things will happen that here. So here you can see from the height h, from the ground, there is the one fighter jet and that is flying in this direction. Okay, and let's take initial velocity is how much here? U. Okay, so when bomb will be dropped, what will happen? The bomb will get the trajectory of this one, this yellow color. But this trajectory will be observable when a person is seeing from the ground. But if the same person who is sitting in a plane is going to see the bomb, then what kind of trajectory he will see? For that we have to see the relative motion of the bomb with respect to a person sitting in a this one here fighter plane, is it? So let's see here. So we know very well, first thing, I am considering that this bomb is falling downward. Obviously it will fall downward, and this fighter jet is flying with a horizontal velocity, and this velocity is uniform. Okay, so remember that here, if I talk about here the velocity of the plane in this direction, you know very well here, this is u, and horizontally that means I cap. So u I cap, constant velocity. After that, if I write here the velocity of the bomb, okay, one bomb is there. So you know very well the bomb is following which trajectory? This trajectory. So at any instant, if I write here, let's take at this instant. So at this instant, the bomb will have the two velocities. So one along a horizontal direction, and as the bomb is dropped from the plane, it will get the velocity of the plane only. So what is the velocity? U, because there is the no change in acceleration along x direction. This acceleration is always 0. And one velocity will be downward direction is there. Okay, so see right here this velocity, and let's take here this velocity I have just taken here vy. Okay, so what can I write here? I can write here u I cap minus vy into j cap. This is a person velocity sitting in a plane, fighter jet, whatever they are giving, and this one is the velocity of the bomb. So as this velocity of the bomb is observed by a person, so we will calculate velocity of bomb with respect to a person. So what this will come here? We can tell velocity of bomb minus velocity of person. Velocity of bomb how much here? U I cap minus vy j cap, and here we can write here minus uy cap. So what other things can be cancelled out? This uy cap is cancelled. That means it is coming here what? We can tell here vy minus j cap. There is only one component in a downward direction is there, along negative y-axis. That means from here it is looking like what? A straight line path. Which path? Straight line path. If we try to understand by the general way, we can see very well here. Okay, so see. So anyhow, at this instant what is happening? The plane and bomb at the same point. So here I can write here P1 and B1. After that what will happen? That here when the bomb will reach here B2, the plane will be here P2, just under the pilot or the person who is seeing it. Similarly, when the bomb is here B3, the pilot will be here P3. When the bomb is here B4, okay, so where will be the pilot? The pilot will be here P4. Similarly here B5 and here P5, plane, pilot, whatever. And when B6, what is this? We can write here P6, is it? So we can see very well the bomb is always down the pilot, down the person who is sitting in a plane or fighter jet. So it will look like a which trajectory? It will look like a straight line trajectory from a person seeing the bomb from the aeroplane. But if a person sitting on the ground or standing on the ground seeing the same bomb, he will observe what? A horizontal projectile. But the person sitting in a plane, he will observe which one? Straight line. Okay, can you remember that? So correct option is here straight line vertically down the plane. Okay, remember that here. Next one, let's see the question. This question is also very interesting. The question is, see, a particle A is dropped from a height and another particle B is projected in horizontal direction with a speed of 5 meter per second from the same height, then the correct statement is what? What kind of statements are available? You can say particle A will reach ground first before B, or particle B will reach at ground first with respect to particle A. Both particles will reach at ground simultaneously, or both particles will reach at ground with same speed. Okay, so here I have taken here the two situations. This is particle A that is dropped, particle B that is projected horizontally. Okay, so one by one we'll talk about here. First I am going to talk about the particle A, and let's take here this height, how much here? H. This is also H only. So you know very well here initial velocity of the particle A, how much here? 0. Na initial velocity at point. What is the meaning of this? We can write here particle A along x direction also 0, and particle A along y direction is also 0. Okay, so in this situation, when you will use equation of motion like s equal to ut plus half at square, you know the basics very well. So time of descent for particle A will come how much here? Root 2h by g. Is it? You have to just use s equal to ut plus half at square. Okay. After that, if I talk about here this one here, second one. No. So let's take here. This is projected in this direction with u. U is given how much here? 5 meter per second. Projected horizontally. That means, is there any component in vertical direction? No. That means we can write here for particle B, there is the, how much is there? If I write here in a vector form, I can write here 5 into I cap. Okay. Or in a component form, I can write here UBX is a U, or 5 meter per second, and UBY is how much here? That is the 0. So remember that here in this situation, this thing is very important. This one is having vertical velocity, particle A 0, and particle B is having vertical velocity how much here? 0. And for time, vertical component is responsible. Is it? So here also, when you will simplify this, no? Very basic thing, even you remember the formula also, this will also come TdB equal to root 2h by g. That means here time also root 2h by g, here time also how much here? Root 2h by g. That means both the particles will reach the ground at the same time. Particle A, when it will be dropped, it will reach here. Okay. And when particle B is projected by following the projectile path, it will reach here. So here we can tell both they will reach at the same time on the ground. But here range will be how much here? Here range will be 0 because no horizontal component. But here range will be this much here. And what is the range formula? You know very well here. Ux into Td. Range they did not ask. So we don't bother here. So which option will be correct here? No, you can see even the options are here itself. See, both particles will reach at ground with the same speed. Okay, and the question is here. This is our question. So remember that, very important. They ask in a NEET 2002. Okay, great. Now let's see the next question is here. The question is, a child stands on the edge of cliff 10 meters above the ground and throws a stone horizontally with an initial speed of 5 meters per second. Neglecting the air resistance, the speed with which the stone hits the ground will be how much here? Okay, so let's see here. This is the point A is there, and from here the stone is thrown in horizontal direction u, and on the ground it is going to strike here. So you know there is no air resistance. That means anyhow the gravity will act in downward direction. Okay, and there is the no acceleration along x direction. So what will happen that here, when it will strike the ground, horizontal velocity will be same u. Okay, and horizontal velocity will be same. I can write here this one here. Let's take here Vx will be u. After that, because of the falling, what will happen that here, it will get one vertical velocity in downward direction. And what is this vertical velocity formula? Remember that here, g into Td. In last video I have taught. Even it is called root 2gh also. If we use the time of descent root 2h by g, then you will get here. So what is the resultant velocity? For the resultant velocity, we have to just draw here one rough parallelogram like this. Okay, and this will be the velocity resultant is there. Okay, and this is called here what? I will tell here Vb. Okay, and this should be go in the same direction like this. Okay, so we'll just get here. So we know very well here, if I write here the velocity in a horizontal direction, what is given here? Vx is equal to u, and with whom, how much velocity we are throwing, you can see it will be given somewhere, this one, you see 5 meter per second, 5 meter per second. Similarly, in a y direction, what is the formula? See, root 2h by g. So 2 into 10, anyhow g value, I am going to use 10. And height, how much is given here? You can see 10 meter. This height h is given here 10 meter. So we can write here 10. So this will come here what? This will become here root 200 meter per second. Then again, we'll use this parallelogram method, and you know very well, velocity at the ground, we have to just use Vx square plus Vy square. So Vx square, that means 5 square plus root 200 square. So what we can write here? Very well, this is 25, this is 200. So root 2 to 5, or we can write here 15 meter per second. The resultant velocity at point B, that means at this point, will be how much here? 15 meter per second. In that horizontal component 5, vertical component root 200 meter per second. Okay, very basic question, JEE 2023. Now let's come to the next question. The question is here: a helicopter is flying horizontally with a speed v at an altitude h, has to drop a food packet for a man on the ground. What is the distance of helicopter from the man when the food packet is dropped? Okay, and this kind of options are available now. So they are asking distance. So you can see very well here, what is given here? Plane is given here, the helicopter is there. Okay, helicopter. So here helicopter is there. So let's take here, helicopter is having one velocity u in this direction and man is here. What is the height of the helicopter? H, and you can see very well, this will be the range. I have taken here r. Now, so when the packet will be dropped here, it will follow the parabolic path and it will reach where? It will reach to the man. We have to calculate the distance. So to calculate the distance, we can just get it here like this. See, this will be the distance. This is the distance. Okay, this is the distance is there now, because man is going to see the helicopter. Here helicopter is there. This is the helicopter. Okay, so here we can just write here this initial velocity. If I write here in horizontal direction, what is given in the question? V. Okay, so we have to calculate here the distance. To get this distance, we can see the triangle. If we know r, then we can use the which one? We can use this right angle triangle Pythagoras method and we'll get the answer. Okay, so see here please. What is the range formula? Range formula we know very well. No, range formula we know very well, u into td. Okay, because here time how much here? 0, and after reaching here time how much here? td, that means time of descent. Okay, so what is the ux into td? What is the velocity in horizontal direction? V, and time of descent, what we can write here? Root 2h by g. Is it? So r we have got here. After that we'll use here the triangle. In this triangle by Pythagoras theorem, what can we write here? We can write here d, this distance is equal to r square plus h square. Okay, so r square is what here? Kindly see, v square into 2h by g plus, and this h square is there. So you can see very well, this distance is coming this one, square root of, this is the expression. So kindly see anywhere, v square into 2h by g plus h square. This is the answer. Correct option is here, option C is the answer. Okay, very basic question. Now let's see again. The question is here, see, a helicopter flying horizontally with a speed of 360 km per hour at an altitude of 2 km drops an object at an instant. The object hits the ground at point O 20 seconds after it is dropped. Displacement of O from the position of helicopter where the object was released is how much here? Displacement. Okay, and in previous question also they are telling distance, but by default we will take here the displacement, remember that. Okay, so let's see here please, they are asking here the displacement. So displacement we know very well, what is the height? Any height they are giving here. Altitude how much is given here? 2 km. This is the altitude. Okay, now after that range we have to calculate. What is the range formula? Range we know very well here, ux into td. Okay, so it is flying with how much here? 360 km per hour. 360 kilometer per hour. Make sure that kilometer per hour into time. Time how much is given here? 20 seconds. We have to convert into what? R. That means 3600, and here it will become here R. Now, so what will happen that here, see this R cancelled, and from here we can write here this is cancelled 10 times, then 0 also cancelled. So how much is coming here? This will be the 2 kilometer. Height also 2 kilometer, range also 2 kilometer. Then again we will use here the displacement formula. See, this one is here. See, this is the, I am considering here displacement. Okay, and here in the question also this should be what? This is the displacement. Remember that here. Okay, based upon the options. So what is the displacement? We know very well here. This displacement is given here is square root of h square plus r square. So we know very well here. This is 2 kilometer square plus 2 kilometer square, and this will become here what? 2 root 2 kilometer, because options are in kilometer. So why we should go in a meter and all that? Directly all the things will solve in a kilometer and kilometer per hour and all, and conversion of the units and all that. Okay. Now students, let's see the last question is here. See, a ball rolls off the top of a stairway with horizontal velocity u. The steps are 0.1 meter high and 0.1 meter wide. The minimum velocity u with which that ball just hits the step 5 of the stairway will be how much here? Root x meter per second. Then what is the value of the x? Okay, so let's take here, these are the steps. This is the, from here steps starting, and from here the ball is projected, now rolled with how much velocity? They are telling you. Okay, and the ball has to hit the step 5. So you can see very well here, when from here it will start, it is going like this, and it will reach here step 5. Now you know very well here, to hit the step 5 the ball should cross the step 4, then only it will hit the step 5. Okay, so remember that here, from here to here this is my height h. How much height will be there? You know very well here, each and every steps are what? 0.1 meter high. So see please, this 1 2 3 4, is it? So we can write here 4 into 0.1, how much is given here? This height 0.4 meter. Okay, even if we talk about here the range, this will be the range. This range will be how much here? Again you see here, this is 0.1, 0.1, 0.1, 0.1, 4 times. That means this range is how much here? This range is also 0.4 meter. Okay, so we know height, we know range, and we have to get the value of u. Okay, so for that we'll just use here the formula. What is the range formula? Range formula we know very well here, u into td. Time is not given, so time of descent I can write here r by u. Okay, after that we can write here, see, if I calculate here the height, for height we have to just apply equation of motion, second equation in vertical direction. All these things I have taught in a previous video. So this will become here half g td square. So here I can write here, see, half g, time of descent I will replace here, so it will become here what? R by u square, is it? Now we'll just simplify this. So from here if I write here, see, h equal to half into g, and here r square by u square. So from here what is the u square? You can see very well, gr square by 2h. So from here what is u? U we can write here square root of gr square by 2h. Okay, let's put here the values and all that. Okay, so let's take the value of g. I have taken 10. R square, R what we can write here? You know very well here, 0.4. So 0.4 into 0.4. Okay, 2. Height how much here? Height is also there, 0.4. Okay, so let's cancel out what other things can be cancelled. This 0.4, this 0.4 cancel. 10 into 0.4 means 4, and 4 by 2 what is coming here? Root 2. Root 2 meter per second. This root 2 meter per second we have to compare with the root x meter per second. Then what is the value of the x? The value of x is 2. Okay, can we see here? So students, I hope so. This video based upon the questions of horizontal projectile motion is very clear to you. Keep studying, keep growing.